So, circular motion. What is circular motion? Circular motion is what we are studying. So, what is circular motion? Circular motion is it refers to the movement of an object along the circumference of a circle at a constant or varying speed. It can be classified into two types as well. So there is uniform circular motion and there is non-uniform circular motion. So the uniform circular motion has a constant speed because it's the kind of motion where the an object is covering the same distance in the same time. For example, if if a car is moving in a circle and is covering a circumference of, let's say, 10 meters in in maybe 5 minutes. So a car moving in a circle of circumference 10 meters in 5 minutes. So every if the car keeps circling that distance, assuming it's a field, for example, a field. So a car keeps moving around the field and it keeps covering the field, the circumference of this field in in 5 minutes. Let's just say 5 minutes. So if the car continues to do that, the distance or the distance of the field does not increase and it will not decrease as well. So if the car continues to circle that field every time, then it means the car is undergoing a uniform circular motion because it keeps covering the same distance in the same time. That is a constant speed. But a non-uniform um, circular motion will be a motion that has changing speed. So let's say a car is moving in a circle, but it's covering in different distances in different time or in time. So let's say maybe a car is moving round a field, and as it is moving, it keeps going towards the center, right? Something like this. Let me see if I could. So maybe a car keeps doing this kind of motion, this kind of movement. Oh, I can't. So I couldn't do what I wanted to do, but if you can watch my cursor, the car keeps doing this, doing that, and eventually gets to the center, forming a spiral motion until it gets to the center. Then that kind of motion is not uniform. It's not a it's a non-uniform circular motion. And then we look at key concepts in circular motion. Key concepts in circular motion: angular displacement. Angular displacement is the angle through which an object moves on a circular path. The angle through which an object moves on a circular path is measured in radians. We measure angles in radians. You are used to degrees, but actually angles are measured in radians as well. So the formula for this is S over R, where S is the distance covered over R being the radius. R being a radius. I would I'd love to show you this, but I can't seem to show it on this platform now. But I will still send you another note as well, just so that you will understand better. So where okay, as you can see, where S is the arc length, that is the length of an arc. An arc is just a curve in a circle. So S is the length of an arc, and R is the radius of that circle. So this is a question, an example that you can that has been done. A car moves 10 meters along a circular track of radius 50 meters. So calculate the angular displacement. So here, the 10 meters represents the arc of that circle, because they said a car moves along a 10 meter, a car moves 10 meters along a circular track. So it means it moves a curve, a bend, and the radius of that circular track is 15 meters. So we just divide to get our angular displacement, s over r, that's 10 divided by 50, to give 0.2 rads. Also, angular velocity. Angular velocity is the rate of change of angular displacement. So, we have dealt with linear motion, where we look at linear speed, linear acceleration, and linear velocity, and all those things. Linear means straight line, right? So this time around, we are looking at angular motion or circular motion. A circular motion will have to do with bends, curves, angles. That's why angular velocity this time around is going to be the rate of change of angular displacement. For a normal linear motion, we'll just talk about velocity, not angular velocity. We'll talk about just displacement and not an angular one, because it's a linear motion, a straight line, movement in straight lines. But since we are looking at movement in curves, in circles now, then we'll be talking about angles, angular displacement, angular velocity, because every movement you'll be making will be forming an angle. I hope you get it. So, angular velocity is measured in radians per second, rad per second. And then the formula is going to be the change in the angular displacement divided by the change in time. As the normal velocity we know in linear motion is change in displacement over change in time. This as well is change in angular displacement over change in time. So here again is another example. A Ferris wheel completes one full rotation, that is, it goes one full circle. A Ferris wheel is that, anyway, you could check it up, but if you don't know, is that circular, if you go to amusement parks, that giant circular thing that people sit in that that rolls up. It looks like a very big wheel that people sit on, and it goes round and round. So that's what a Ferris wheel is. So it said a Ferris wheel completes a full rotation of 2 pi radians in 30 seconds. Now let me explain something to you. Pi, a pi in radians represents 180 degrees. So if you are saying 2 pi radians, then you're talking about 360. So saying that's why it's a full rotation. 2 pi radians. 2 pi is 360 degrees in 30 seconds. So the Ferris wheel completes a distance or an angular displacement of 2 rads, 2 pi rads in 30 seconds. So what is its angular velocity? So to do that, you're going to divide 2 pi radians by 30 seconds. So it's going to be 2 pi divided by 30. I can see that there's a mistake here. I've made a mistake here. I didn't put the division sign after the 2 pi. So there should be a division sign. That's 2 pi divided by 30, which is equal to 0.21 radians per second. Please ignore all this after it. These are mistakes, please. So the answer is 0.21 rads per second. On your calculator, you can put your calculator in radians to do this. Or you convert this 2 pi to 360, divide by 30, then your answer you change back to radians. You change your answer back to radians. Okay? To do the conversion, if 2 pi is 360, then the answer you get will be what in radians. That's how you're going to do it. So the next is tangential velocity. Tangential velocity. A tangential velocity is the linear speed of an object moving along the circular path. So if imagine, for example, that you tie a stone in a circle and then you're whirling it around, you're rolling it around. You tie a stone to a rope or a thread, and then you are rolling it around fast in a circular motion. And suddenly the the stone flings off. The stone just flings off. What is going to happen? The stone is going to fly off in a direction that is tangent to the circular motion it was making. Okay? The rope is going to fly off in a direction that is a tangent to the circular motion it was moving with initially. So a tangential velocity is the linear speed of an object moving along a circular path. So if an object flies off while moving in a circular path, the velocity it flies off with is called a tangential velocity. So I'll repeat myself. When an object is moving in a circle and it suddenly flies off, it's suddenly flung off that circular motion, the velocity it flies off with is called a tangential velocity. And the formula is given as V equals R omega. V equals R omega or omega R, whichever way you want to put it. So here again is the formula and an example. A stone is tied to a string. A stone tied to a string is swung in a circle of radius 2 meters with an angular velocity of 3 radians per second. The tangential velocity is what? So just put in the appropriate the omega and the r. R is the radius of the circle, and now omega is the angular velocity of 3 rads. So just multiply that together to get the tangential velocity. So next is the centripetal acceleration. Centripetal acceleration. Centripetal acceleration is an acceleration that is always directed towards the center of an object undergoing circular motion. Now, when an object is moving around in a circle for a uniform circular motion, so I said before that for a uniform circular motion, the speed is constant. An object undergoing a circular motion, a uniform circular motion, has constant speed because that object is covering equal distance in equal time. The object is covering equal distance, which is the distance or the circumference of the circle, in equal time. So the speed is constant, but the velocity is constantly changing. At every point in the circle, at every point in a circle, if you are walking in a circle, huh, just try to walk around in a circle. At every point, you will be facing a different direction. At every point you turn in that circle, you'll be facing a different direction. So that is why velocity is changing. And once velocity is changing, acceleration is changing as well. I mean, there is acceleration as whenever velocity is changing, then there will be an acceleration. Okay, so um, for a body undergoing uniform circular motion, the speed is constant, but the velocity is changing. So because velocity is changing, then there is an acceleration, and that acceleration is called a centripetal acceleration. Centripetal just means center seeking. Center seeking is always seeking the center. And that's why when you are in a car that is turning round a sharp bend, we tend to bend towards the center. We bend as the car is turning around a bend, turning around a sharp bend. We tend to bend towards the center of the vehicle. People inside will bend towards the center in the circle, in the vehicle, sorry. So that's known as centripetal acceleration. And the formula is from because centripetal acceleration is known as v squared over r. The formula for centripetal acceleration is known as v squared over r, where v is your um, velocity or the tangential velocity divided by the radius. Okay, v is the tangential velocity divided by radius. Now, if you substitute tangential velocity of v equals omega r here from here, if you put that in the formula for centripetal acceleration, v square over r, then we are going to have r omega divided by r omega divided by r. Then if we readjust the formula, we are going to have centripetal acceleration as r omega squared. So there's another example here that I don't know why this is blocking it, but if you can see it, there's another question there and it has been worked out too for you. So we have centripetal force. Since there's a centripetal acceleration, then there will be a centripetal force on an object that is moving in a circle. Force equals mass times acceleration. So in the case of a circular motion, the force will be equal to mass times centripetal acceleration. Now remember, centripetal acceleration is v squared over r. So centripetal force will be n v squared over r. And that's the formula there. And we also have a question, an example. These are simple examples that you can go over on your own. So here are real life examples of circular motion. So I'm just using this to help you remember what you may have done before, to reintroduce you to this topic, circular motion. Okay, so I hope this helps you.